Hi, today I would like to see this coding problem of disk stacking. And so the input array for this coding question is disk, which is a list of lists, and this each list is a disk with three numbers, that is width, depth, and height of the each disk. So the conditions for what is the question is, so what are the disks that can be chosen among the given disks, such that their width 1 less than width 2. So it means, so we need to stack the disks in an order, um, like just like this. So and such that, so this width is lesser than the below one. Similarly, the depth is lesser than the bottom one, all the ones. So similarly, height is less than the h2. So based on this condition, what is the maximum height that we can produce from the disk chosen from these given disks? Okay, so how to deal with this problem? Okay, so this being a dynamic programming problem, mm, so what is my initial thought is, I need to mm, sort the heights of the disks, sort the just heights of the disks, and I will try to find the maximum sum of the heights by, uh, I will I will make the sum by choosing iterating iterating two for loops, and uh, so finally I could find the maximum sum that I can generate from the heights array. I will create a heights array. Okay, so and afterwards, based on then we will get the maximum sum that we can produce. Then using we will track that index where the maximum sum appeared, and track back we will track back to the starting point, that is from bottom disk to top disk. Okay, so okay, I will initially sort this disk array based on the heights of the disk. So this is the 1 3 1 2 1 2 3 2 3 2 3 4 4 4 5 2 2 8. I just sorted the disks array based on the heights. That is the third element of each list. Okay, so afterwards I will just create a heights array, and it will contain the heights, just the heights 1 2 3 4 5 8. Okay, so now the thing is, as a dynamic programming problem, we need to take the smaller parts of a bigger problem. So as a new that, okay, so I need to iterate through this array once. Say for example like this, I will iterate um, this. My say I want to find the maximum sum that we can make, and we need to consider these condition while choosing the maximum height. So I will try like this. I will first iterate through this heights array for I in range length of. So one thing here is I will start with not with 0. I will start with the first index. Length of disks. Disks and heights are same. So okay. And what I will do is I will take the say for example I want to calculate some current disk. Say current disk. How will I get? Disks of I. Disks of I. And I will iterate. Say if I want to calculate this as a current disk, the other disk would be less than this. So for j in range, it will iterate from 0 to 0 to pi. Okay, so it iterates from here, and the other disk would be say it ranges from here to here. So other disk is equal to disks of j. Okay, so okay, after I just iterated through this, through the two for loops in the heights list. So I can what the basic formula for this DP problem is. So how will I check this? So primarily this condition has to be matched, that is W1 less than W2. So if I will just write a small function that is or what is called, these dimensions are valid dimensions. Valid dimensions, and I will pass the other disk and the current disk through this. Other disk, current disk. So disk is, I mean, this sub list. Okay. So what this will do is, so this function is just like this. So this definition of are valid dimensions. It will take other disk and current disk. So it will check. It will return. It will return other disk O of 0 is strictly less than. So by the way, this has to be strictly less. This first width is less than the second width. So it is not equal. So strictly less. So this is current disk. So current disk of 0 and other disk of first index less than current disk of first index, and other disk of 2 less than current disk of 2. Okay, so this will return true or false, and this evaluates here if true or false. So okay, if true, if this condition is satisfied, if the first disk or the top disk has width, depth and height having a lesser dimensions than the bottom one, so what we need to do, we need to update these heights. That's what we are trying to find, the maximum height that we can make out of these disks, and just make a backtracking sequence for getting this. Okay, so so in this under this if condition, so I will write something like if is heights, if the heights at a particular index is less than, if the heights is less than or equal to, is equal to height of heights of I, sorry, it's heights of j. So what I'm doing is I currently noted this for, say for example, height of 0, 1, 2, 3, heights of 0, I when I is equal to 3, I'm just checking. So is height of j, is height of j, j means j is less than 0 to 0 less than mm, j less than I. So I will iterate through this. Say for example, if 2 is there, so if 2 is there, I mean 0 on first index. If height of j plus, so I need to add this. So I need to add the height of, or whatever the current disk. I need to add disks of second. We have already stored this, right? So instead of calling disks of um, I of 2, I'm just trying to add the height which is present for the disk. So I will just call um, the current disk with height. This is the height. So what I'm basically checking is if I want to update anything at the height index, I'm just adding or checking. So if the sum of the previous heights plus any the plus the height of the current disk, say if the 0, 1, 2, 3, this is third index, so I will just check 0, 1, 2, 3, this index height plus any of these through the iterations. So plus j, is it less than or equal to? So what does this mean? So this value is higher than the existing one. So what we can do, there is possibility that after passing this condition of, after passing this condition, there is possibility that, so there is possibility of a higher height. So what we can do, we can just update that heights of heights at that index to whatever sum which we got from here. Heights of j plus current disk. So this is the basic formula. So for this calculation. So we have checked the height and we have updated the height. And at the same moment, we need to so store the sequence. So for storing the sequence, what I can do, I will just create a sequence array. So this is helper function. I'm going to run this. So I will just create in the top, I'm writing here the same thing. So I will create something like sequences, or I will write at the correct place. So I'm going to run this. So the finally this is the answer. So we will keep this. I will create the sequences here. Sequences is equal to I will initialize with maybe nuns or minus ones, or I will initialize with nuns, that is equal a length of disks length. So what the sequences contains, it contains nuns which is equal to the number of the size of the disks. So what I will do, I will just update that sequences sequences list at an index I. So with the index j, so what does this mean? So I am updating the position, the num value here with with your index j, which we calculated that okay, this is making more height, maximum height than the previous one. So I am updating that. Say I maybe it's updated to 2. Okay, so we need to use this for backtracking, for getting this value, for getting the exact. Okay, so after checking these conditions, we have saved the sequences, and yeah, we need to get the actual sequence. So finally, this is the basic formula, basic logic, core logic for this problem, and we need to return actually for this function. So return, I will I will call another function for the sequences. So get sequence, and I will pass so parameters like disks. This function will actually generate the sequence, this exact solution. So get sequence, this will take parameters like disks, and as I'm saving these sequences here, these sequences, and we need to pass one more parameter, that is the position where the last index happened, the maximum height happened. So for that, what I can do, okay, finally up to here, what we, after iterating through this for loop and if condition up to here, what we will get is we will get some um, we will get the sequences. So sequences, say for example, it has become num 1 or num 2, 3, say. So we have got the maximum height or maximum value here. So we will track that maximum height by declaring a variable here. So we will take maximum index, maximum value index, we will just initialize with 0. Okay, so this is the for loop, right? So after each for loop, after this condition, we will just call, just check a function. If for checking the whether the maximum height, maximum index has been changed. So the if the heights at, we are exactly writing below this for loop, we are checking for heights, heights of I, is this less than or equal to. So I am checking less than or equal to, so the last value will be taken. So the last value which became equal, the index that would be chosen. So heights of I less than or equal to, hmm, so so if I less than or equal to, what I can check with. So yeah, I can check with the maximum index. So if the maximum index is that value, heights of maximum index. Okay, what does this mean? Okay, we actually need to writing the reverse order. So what does this mean is, so we are checking I. So for any heights, any other heights, is there any other heights that has a bigger value than the heights of 0, which was maximum index is equal to 0. So if you found anything bigger than the maximum index heights, then update the maximum index value, update just the index to the new index, so that that would become the maximum index. Okay, this maximum index would be sent here for the sequence. So what we will do in this get sequence function, we will we will start with the maximum index and backtrack. Okay, okay, so regarding the timer space complexities, so this is iterating for loop for a twice of time. So it is of time complexity is big O of n square, where n is the length of the input array. And space complexity, in the process we are creating the heights array. Disks we are just sorting in place. So heights array we just created, so it is big O of n. Okay, we will write the get sequence method now. Okay, I will see. I'll keep the sequences. None. Say for example, I'm just writing two. Okay. So definition of get sequence. It will take the disks. I can call it any array or something. I can just call the disks also. Sequences. Sequences is the one which stores the none value which we initialized with nuns, and after updated through this sequences of I is equal to j. So what does this mean is, in the location of this ith index, in the sequence array, it will store what is present on the top of that, mm, the disk which is present on the top. It will store that. So sequences and the maximum index. I can call current index too, or maximum index. Nothing fine. So it will take the maximum index. So okay, I will just create the sequence empty list. So this is the one which is going to return this. So I will check while sequences, while current index, while current index is not none. Okay, so okay, if the say for example, if the sequences array is like this, so what does this mean? As we know, so it is stating, so this is the bigger index, go to front, and we will go to the forward until the none is found. So while current index is not none, so I need to append what is present. Sequence dot append the element which we are calling a from the list array of this number. So I'm just going to append this number. So how can I append this array of whatever is present in the, I will just call current index. Okay, so after appending one element, one disk, so we need to update the current index, right? current index, so update it to what you will update it to. So as we know, for backtracking, going to from the original maximum number to the forward, that 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 value is stored in the sequences. So just call sequences at this current index. So just calling this, so this value gives the index which it need to backtrack to. So just store that value, that index, in the current index variable. So this will get updated until it reaches to the first none. So it completes the none and we will get the sequence. So just return sequence sequence, but excuse me. So little thing is, so this sequence is what is happening is, while appending, so we are coming from back to front. That means a bigger disk to the smaller disk. I mean the down disk to down to top. So we want from top to bottom. So we just need to. So I will graphically tell that. Okay, so what we are appending is, we are appending bigger disk. We are appending little smaller disk. So we need to give the list in such a way that this is the order. So we need to give from top to bottom. So we just need to reverse that. So how can we reverse this? We can call reverse to the sequence, and to make this will give you a iterator. So just need to make it list. So that's it. So this will return the correct order from starting to the top to bottom, satisfying this condition w1 less than w2. And this is the maximum height that we can make by this code, by this problem, 2 plus 3 plus 5, which is equal to 10. Yeah, I think that's it. We talked about the little bit conceptual time and space complexities and the theory of this code implementation. Yeah, that's it.